Good afternoon and welcome to this breakout session on textile transformation, part of the Circular Materials Conference Online 2021. The transformation to a circular economy is doing a couple of very interesting things. First of all, it's throwing up just some of the craziness of our linear model that we have currently, maybe none more so than in the whole world of textiles. Is that how we have organized things? Extraordinary systems we have in place. Transformation is the order of the day. And in this session, we've got a number of speakers who are going to share with us some of their research and action work, which is part of that transformation towards true circularity within the textile area. Huge challenges, but also some very exciting opportunities. So we look forward to hearing from each of our speakers. And then I hope at the end we'll have a little time for just a little bit of kind of strategic thought as to what's this telling us? The more we get into it, is it getting more complicated, or are we seeing light in the direction of a circular future? My name is Peter Woodward. I'm an independent moderator with a passion for sustainable development. But the person and the people you really want to hear from are experts who are involved in different projects. And right from the start, we're going to go to a really fascinating project looking at the whole issue of large-scale textile sorting in the Nordic countries. What are the challenges and opportunities? And I'm delighted we're joined this morning with colleagues from Wargön Innovation Park, which are doing some really interesting work on textile sorting, both for reuse, redesign and recycling, and looking at it at scale, which is a key issue. So I'd like to bring in right at the start Maria Ström, who's head of innovation at Wargön. Maria, great to have you with us, and even more wonderful to see that amazing innovation building behind you. So really interested to hear some of the work and particularly the learning that is going on in your world, and whether it's going to give us heart that the transformation to circularity in textiles is well on course or not. So Maria, over to you.
Thank you so much. It is well on course, but it is also a challenge, and I'm sure that many of my other colleagues this afternoon will share that with me as well. So I will start by sharing my screen and show you some slides and also tell you a lot about Wargön and textile sorting. Okay, so I will start by informing everybody here that I am sure you know of, but our audience may not know that EU has launched a new directive for collection of textiles, which will be enforced by 2025 in all EU member states. And in Sweden, we will implement producer responsibility for textiles by 2024. And as you say, Peter, textile industry is facing a change in paradigm, and it absolutely is textile transformation, as is the name of this whole session. We need to have a broad perspective on textile transformation and innovation is also one of the key success factors to succeed in this. And at Wargön Innovation, we recently put an automatic textile sorter, the fiber sorting operation, making our pilot plant for textile sorting more complete. And today I will talk about the challenges and opportunities with textile sorting, and why and how innovation can enable large-scale textile sorting. And also my colleague Susanne will give you a virtual tour of our pilot plant facility for textile sorting in Wargön. And as Peter said, my name is Maria Ström and I am innovation leader at Wargön Innovation, and we are part of Science Park Innovatum on the west coast of Sweden. But first, a few words about Wargön Innovation, where I work. Our mission is to enable production of tomorrow's materials, and this is done by offering an innovative environment, including a test and development facility for materials. The goal we have is to decrease carbon dioxide emissions. We often use the gram kiloton scale and symbol that you see on the right here, and we guide ideas on their journey to commercialization. We have a focus on small and medium-sized enterprises, and we work in parallel with both business and technology development. And we collaborate a lot with more than 100 different actors within businesses, universities, institutes, NGOs, and public organizations. We are publicly funded by the European Regional Development Funds and also by regional and municipality fundings. And on the photo, you can see big windows, and in there is where we operate, and you will also see the inside of that when I introduce Susanne later on. But first, we will take a few steps back and look into what we really face here when it comes to textile challenges and going circular. As you can see to the left, the global textile consumption is increasing continuously and enormously. And today, the yearly consumption is about 100 million tons a year. And only in 10 years, it is forecasted to be about 146 million tons. And in 2050, the figure is almost tripled. This is a very big challenge. And as you can also see on the right-hand side, there are big environmental effects on consumption of textiles and other crops that you grow in the area of the ROC. You have to irrigate cotton a lot, and as for now, we have about 30 million tons of cotton grown every year in the world. And this is taking a lot of fresh water, and as a consequence, and also as a consequence for other crops that are grown in the ROC area, the ROC has disappeared, and this is of course a terrible thing to see. We also see other trends, like since the year 2000, there is a growth of clothing sales and a decline in clothing utilization. We are buying more and more clothes and use them less and less times. As we can recall from the previous slide, the global consumption is about 100 million tons per year, and the corresponding figure for Europe and the Nordics is 13 million tons a year and 375,000 tons respectively. Only 20% of all of these volumes are collected for use or recycling, and the rest goes to incineration or landfill, which means that about 80 million tons of textiles are wasted every year. So how are we doing with the textile circle, as you spoke about, Peter? Well, these 80 million tons a year of textiles goes to incineration or landfill. And you can see this very simplified illustration of a textile circle, where you can also see that there are a lot of things in the circle that we need to address to be able to get to circular textiles. At Wargön, we are focusing on collecting and sorting, and you can see that in the yellow on this picture. And we also cooperate with actors in all parts of this circle. Here on the Swedish west coast, we have close cooperation with RISE, for instance, that is strong on recycling and production. And we also work a lot with Borås School of Textiles, who covers redesign, design for longevity, manufacturing, and consumption. And to oh, I got a message here. Sorry for this. And to become circular, we need to work on both reuse, redesign, repair, and recycling, as well as we have to develop new business models and better ways to make use of the textiles. When the garment has reached end of life, it should be recycled, but today only 1% is recycled into new textiles. Nevertheless, for both reuse, repair, redesign, and recycling, there is a need for efficient textile sorting facilities. And in Europe, we only collect about 2 to 3 million tons a year of these 13 million tons. And of that, about 35 to 40% is directly exported to other countries for sorting. So you can see that we have a big lack of sorting capacity. And in 2025, when the new waste directive is effective in Europe, this amount of 2 to 3 million tons will increase enormously, and we will have a very huge lack of sorting capacity in Europe. But there are challenges to address when you think of sorting capacities and why is it not happening. This is one of the reasons. On this slide, I want you to focus on the blue parts on the pie charts. To the left, you can see an illustration of volumes for different grades of textiles, and on the blue parts, you can see cream and next best quality adding up to about 50% of the whole volume. They are fairly easy to sell these volumes as they have a good value. But if you see on the right part, you see that the blue chart parts adds to about 97% of the value. So actually 50% of a big textile pile that you collect has almost nothing in value. And this is volumes that need to be recycled. And of course, you need to find innovation processes and so forth to get this big pie to be valuable again. And also on the next slide, I will show you some different kinds of textile recycling possibilities, which will furthermore make this picture more complex. Here you start on the top left corner, and you can see that we collect textiles, we sort them manually for reuse, repair, or redesign. But a fairly big fraction need to be furthermore sorted, and that has to be put into more material-based sorting. For instance, you need to know, is it cotton, is it wool, or is it a blend of polycotton, or what is it? And depending on what kind of application you are sorting for, you need to have a specific automatic sorter to be able to sort in these different material compositions. To be able to sort of fiber types, automatic textile sorting is needed. And here in Sweden, we now have 2 initiatives for that. The industrial SIPTex facility in Malmö that Erik Perzon from IVL will describe later today, and the textile sorting plant in Wargön. We are both operating by using NIR, near-infrared spectroscopy, to recognize fiber types in textiles. In our pilot plant in Wargön, we also sort for reuse, repair, and redesign. And we combine both manual and automatic sorting, as you soon will see in the film. And after the film, I will also talk a bit with my colleague Susanne, and you will have a glance of what it looks like inside Wargön. But first, I will show you a film about how the machine works at our facility.
Nu har vi fått vår nya skanner installerad. Det är den vi ser bakom oss. En stor blå låda, men det spännande finns ju i lådan. Där sitter det sensorer av olika slag som kan känna av vilken fibertyp det är, vilken färg det är, om det är mönster. Och i dagsläget kan den känna igen ungefär 46 olika kombinationer, men sen kan vi lära den väldigt många flera. Och det är del av det spännande vi gör här. Plaggen kommer in en och en i skannen. Det tar ungefär 1 till 2 sekunder att skanna av ett plagg. Och när de har passerat sensorn skickas de vidare och i sina olika fack.
EU kommer ju komma med krav på insamling på textil till 2025 börjar de gälla. Och då krävs att alla länder i EU samlar in textil och har en organisation för det. Här i Sverige har Naturvårdsverket satt upp mål att vi ska samla in betydligt mer och att en stor del av det även ska gå till återvinning eller återbruk. de sitter ju och lägger på textilen där och så går de upp längs med bandet här till skannern som är den stora blåa lådan.
Vi började med att ta fram den här linan och anläggningen som vi står i. Och sen har vi tittat på olika automationslösningar. Vi har haft studentprojekt, vi har examensarbetare och även forskare som har tittat på arbetsmiljö, tekniska lösningar och varit med i uppbyggnaden.
Vi kommer att få ta hand om väldigt mycket material som vi inte tar hand om idag, men möjligheten är ju också att vi kan konvertera det här materialet till nytt material eller ännu hellre kanske sälja kläderna en gång till i det fall de är fullt användbara.
Därför har vi då byggt upp den här test- och demoanläggningen för sortering av textil. Och det har vi gjort dels för att bevisa den här tekniken och flera tekniker för att det ska fungera i storskalig sortering. Men det är också för att vi ska kunna hjälpa olika entreprenörer som vill utveckla återbruk eller återvinning av textil.
Här har vi ett exempel på vad skannern kan klara av, eller hur?
Ja, precis. Här har vi olika material som känns väldigt lika. Här ser vi då polycotton och det känns så här. Och sen har vi då ren bomull som känns nästan likadant som man kan ta miste. Men polyester kan också se ut något helt annorlunda. Och det kan ju skannern känna skillnad på, men det skulle inte jag kunna göra som med det mänskliga ögat eller känseln. Nej, men det känns ju jättebra att vi har kommit så här långt och har den här utrustningen, den här anläggningen. 2018 fick vi nyckeln till det här huset och då var det helt tomt. Och nu har vi hela det här. Det är fantastiskt.
Okay, thanks. So this is one picture of the interior of our facility at Wargön, but I will stop sharing and also invite my colleague Susanne to take part. See here if I manage. And I do apologize for different technical issues I had, but we hope this will work out fine. So hi Susanne, you are now inside our building. What is happening at Wargön Innovation today?
Hi, well, I'm Susanne Eriksson from Wargön Innovation, and I'm here today at our test and development facility. And right today, we have Renewcell here, a company who recycles cotton, who's testing our fiber scanner to see how it works with their requirements. And it's the textile sorting equipment you see in the background and the famous blue box there with the fiber scanner.
Also looks great. So how much textiles do you sort every day or every year even? What is the capacity?
Right now we sort about 1.5 tons per week, and on a year that makes about 70 to 80 tons. But our goal is to increase that to about the double during this year. But at the same time, the base capacity for this equipment is about 500 to 1,000 tons a year.
Okay. Yes, this is surely a test and development facility, so it's not a big production facility. But can you say anything about the partners we work with on that facility and what they do by using the machine?
Yeah, considering reuse, we work a lot with the Red Cross and a couple of their stores. And within the area of redesign, we do work with a couple of SMEs, and it's like Ray Review, who make high-end fashion from household textiles. And then we have Nimble Patch, who redesigned jeans for children. And then we also have Twood, who makes a wood-like material out of jeans. If you look at recycling, we do have development projects with a company called the Soul Theory, who maybe makes the most sustainable shoes in the world, and also Renewcell, who's here today.
Sounds very good. So in your opinion, what is the biggest challenge when it comes to textile sorting?
For reuse and redesign, I think it's a sorting. I think building up a good competence for textile sorters is a big challenge. There's going to be a huge demand for knowledgeable and efficient textile sorters within a few years here in Europe, I think. And for recycling, I think it's the different fiber combinations in textile today, which makes a huge challenge, combined with a different coloring process and other production processes. We need better marking on textiles like RFID, so where we can have all the necessary information to be able to meet the requirements for potential recycling companies, I think.
Okay, so if I'm listening today and an organization or a company that have an interest to work together with Wargön, how do I proceed?
On our website, wargöninnovation.se, you can find contact information to all of us. So you're very welcome to contact us so you can discuss new opportunities.
Thank you very much, Susanne. Looking forward to that.
Yeah.
Okay, thanks a lot. And I will just have my final few slides ready for you guys and sum up what we have been discussing. So this is a summary of the biggest challenges for large-scale textile sorting today as we see it. And as I have mentioned, there is a big challenge that half of the textile volume that is collected has little or no value. It is also a challenge that the textile sorting capacity is low, and also the automatic sorting capacity is even lower. So that makes up also a big challenge. We also only see small-scale recyclers or redesigned processes. They are existing, but comparing to the 100 million tons of textiles that are put on the market each year, these are still very small scales. We need a systemic change. We need to work together in the textile circle to be able to get this through. And this is no work for a lonely person. We have to be a lot of different competencies that work together to solve this and to innovate on the new textiles as secondary raw materials as well. We lack standardization and confirmation of chemical contents, for instance. We are working on that, or many people are working on that, but we still need to be more coherent and make that happen. And finally, we also do not use digitalization as much as we can do in both reuse sorting and automatic sorting. Having that said, collaboration will be key to succeed with this, and many initiatives are going on. Wargön Innovation is one of the enablers, but we are many more that need to work together. To sum up, there are many challenges, but there are also opportunities. Close by our building, this graffiti sends a message. It has to start somewhere. And we think that is a really good thing to have in mind when you're working on this, because if you never start, you will never go anywhere. So thanks for listening, and I hope that I have given you some insights in what happens in the Nordics. And over to you, Peter. So thank you so much.
Maria and Suzanne, thank you so much. We have had a glimpse of the future, and it's very exciting, but also a reality check of just the huge challenges we face in the transformation. But we've started somewhere, and one of the critical things clearly is a commitment by everyone, producers right through to retailers and consumers, to be part of circularity. And I'm delighted now we're going to move on to hear from one of those producers. We've got Houdini Sportswear, because if companies don't completely buy in to the circularity model, we're always going to be fighting to try and get that transformation happen. But Houdini Sportswear, based in headquarters in Stockholm in Sweden, is one such company that is really rethinking its whole production cycle and its relationship with its consumers. And delighted this morning, I'm joined by Gustav Hedström, who's the head of product as a service. Great title for a job, trying to work out what the implication of circularity is for your whole business model. I never believed that I would be able to hand back a pair of smelly Houdini trainers to you and you'll freshen them up and send them off to someone else. Maybe that isn't the model, but Gustav, great to have you with us and really interested to hear about the approach that you are taking.
Thanks for the introduction, Peter. And in some cases we do, at least with some people, like if you look at the reuse program, people might be tired of the garment they have at the moment and then they can recirculate it, but I'll get back to that. I'll share my screen. Here we go. So yeah, my name is Gustav Hedström and I work at Houdini Sportswear, an outdoor brand based in Stockholm, Sweden. And I'm going to talk about circularity and sustainability in the textile industry. Because today, Maria was touching on it or talking about real good. The textile industry is basically at an unintentional war with our planet. And I'm going to try to explain how we design products and produce products and services that can become part of nature instead of an environmental problem. And there's a lot to talk about circularity and circular economy. And here we have a circular conference and a session about circular textiles. And it boils down to the idea to mimic nature, because nature in itself is circular in a fantastic way. And that's what I'm going to talk about today. And I was happy that Maria, you shared some good fact as well about the textile industry. And I hope all of you listening and us in the group for sure feel like I already knew this. Let's talk about something else instead. But because I'm basically getting tired about talking about the huge impact the textile industry has on the nature. And this is how we want the textile industry in the world to look at instead, where we can give the people opportunity to have a maximum experience when they are in the outdoors without having any negative impact on the nature. And lately we've been adding and beyond, because we believe that zero impact isn't enough. We must move beyond zero and have a positive impact on our planet. And this timeline is almost like, some of you might know I'm a Spotify geek, but the Spotify like 2020 Wrapped, where you realize that you have discovered all the upcoming artists before anyone else. And this is what the timeline is for us, where we have offered Houdini repair since 1995. We have had a closed loop recycling system since 2007. And we released Houdini Rental and Houdini Reuse in 2012. And the goal for 2022 is to be 100 circular, with a growing percentage of the revenue coming from services or circular business models. And for us, it all starts with the design. And sometimes when we talk about design, it's like, what's the next cool pattern, or what material is the trendy one? But for us, it's instead that less is more. It should be versatile and perform. It should be a minimalistic construction that is easy to repair, for example. But it should also be a holistic comfort, where all senses, body, mind, soul, should be simultaneously satisfied. And not only nice to look at, but also great to wear and use. And of course, built to last, so you can have that satisfaction from all your senses for a long time with a durable garment. And that also goes hand in hand with how we think about when we choose materials, and we design for eliminating waste in everything we do, where we see it as everything is borrowed from nature, and we must therefore treat it carefully, and not to extract new resources to make a product. And when it at the end of use, it shouldn't create any waste when it's worn out. And that design like turns into a circular product. And you often hear about this is a circular product, or this is a recycled product. But the definition for us for a circular product is that the fibers are recycled and recyclable, or renewable and biodegradable, depending on kind of like, is it the synthetic loop or is it the natural loop? You could simplify it. And as of today, or the collection that is being in the stores and on our webpage now, we are at 75% of the entire collection that we can call fully circular, which is a super great achievement from the whole design and production team. And if we include the Blue Sign certification, which is basically a certification to say that we have been like not using bad chemicals throughout the whole supply chain and other standards, we are at 100% since I think a year ago, which is also a great achievement. But I don't only want to talk about circularity, because at the same time we never want to compromise with performance and quality just to achieve another good, because just because something is circular, it doesn't have to be sustainable unless you make it like you can't rotate something in a circular system at a high pace, because it's still gonna produce waste somewhere. And the Power Hoodie was released almost 20 years ago, and up until today it looks almost identical, and it's definitely one of our most loved products. And in a survey of I think 700 people, users claim to be using it for almost 1,287 times before discarding it or deeming it like not being able to use it anymore. And that's somewhere between 10 to 150 times more than the average use on the market. And just imagine if this was true for all garments on the market, then we wouldn't have 8 to 10% of the carbon dioxide. Then we wouldn't have to pollute 20% of the all fresh water in the world. Then it would be 110 for 150. And taking one step back or like further out, you could also look at what's the total impact of a person's garment use. So what is the size of the garment or size of the wardrobe, and therefore how much do you use the items in the wardrobe, and for how long time do you use them? How long does the garment last? And what is the impact in the production phase? Because often we only talk about the last one, the production impact, and don't really consider like what's the volume and how long does the volume last, basically. So it's only those three together that can create a like circular system that better mimics nature. And that is what we strive towards, not just circular design or circular products, but also a circular ecosystem where we can not only produce products that are design products that should be used for a long time and that they should be made from circular materials, but also a system that allows for usage over a long period of time. And that one of the key aspects for us is working with circular business model, where we need to find new ways to having access to products and making sure those products are used over and over again. And like I said, since 1995, we had Houdini repair, where broken Houdini garments can be repaired, and we make sure that the lifetime I talked about before can be maximized. Since 2012, we had Houdini reuse, both in our stores, but now since last year, we also have it online. So people can buy used or secondhand Houdini garments, both sell and buy. And we have explored subscription service where users get access to a number of clothes for a monthly fee, and then switch according to their needs, just like a library. and using those, using that, like learnings from subscription, we have scaled up Houdini rental. Before it was only offered in stores, but since a couple of weeks ago, actually, we have Houdini rental online as well, to allow more people to get access to Houdini gear in a convenient way. And I would say, like, there are two super cool things about this, because we own the products, and the longer they last and the more times they're used, the more money we will make. And that means that we can decouple economic growth from the increased use of resources, where we, instead of making money per resource spent, basically, we make money on how much it's used. So we can have more customers without producing more garments. And I want to end with a more like holistic or philosophical thought, where this is like why we do what we do at Houdini. We want to do good. We want to play hard. We want to push boundaries and have fun. And for me personally, play hard and have fun are extremely tightly connected to being out in the nature, and especially having the ecosystem providing me with fresh powder on a winter day when I go skiing. And that also gives like me and us a good motivation to do good, to push boundaries, to try to make the textile industry better. And I know many of like us here in the group, or I know that we share the same motivation, and I hope you listening as well can that us together can succeed in our mission to find a better textile industry, more circular and more sustainable. That's my final remarks.
Gustav, thank you so much. And the marriage of heart and passion with the head of delivering change is maybe the resource we need to take this whole transition forward. So thank you so much for that. Great to see companies such as yourselves really beginning to show how those business models can develop. We still have that huge challenge at scale of those major producers. But at least we are showing a pathway forward. So Gustav, thank you very much for your presentation, really inspiring and informative. We come back to our huge challenge that at scale, we need to find ways of closing the loop. Once we've used the garments, finding ways of reprocessing. We heard from Wargön Innovation Park earlier. Now, delighted to hear another example, and Erik Perzon, who's manager of the SIPTex project, which is the world's first large-scale facility for textile sorting. Erik, great to have you with us. I mean, you're part of the Swedish Environmental Research Institute, the IVL, doing some very interesting work there. The challenge of delivering this at scale and economically is enormous. I hope you've got some insights to bring through to us. Over to you, Erik.
I'll do my best. Thank you, Peter. I will just share my screen here. Hang on. There we go. Sorry, I have some delay here. There we go. So thanks for inviting me. Like Peter said, I'm Erik Perzon. I work at IVL, the Swedish Environmental Research Institute, and I will give you a quick appetizer to our SIPTex textile sorting plant, which is the first automated industry-scale sorting plant for textile waste. Maria set the tone very well, so I will almost skip over a few of these introductory slides. She addressed the issue very well, I think, with the obscene consumption of textiles that we have today. Only a fraction is recycled. Maria mentioned about 1%, and I'm having similar figures. The rest is incinerated or landfilled. Another interesting figure maybe is that for every second today, about a truck full of clothes is going to landfill around the world. And as the consumption will triple, as Maria said, these trucks will also multiply, unfortunately, unless we do something about it. So this is a similar picture actually to what Maria showed, where automatic sorting of textile waste fills a gap. And there's been a gap for some time. The collectors and sorters of textile are having trouble getting profitability. They have very low margins. And like Maria showed, they are generating a lot of unreusable waste that is only pretty much a cost for them. At the same time, recycling technologies and recycling companies are emerging that need access to customized raw material. That means material-specific raw material, which is currently not on the market. All the sorting is done by hand today, and it's only directed to reuse. So anything that is not taken out for reuse is a waste that only induces a cost to get rid of, pretty much. And there's some very low value recycling due to the lack of customized raw material. So that's where automated sorting comes in. We can handle that very low value, difficult waste, and we can sort it with a machine that is cheap and fast, and we can generate more material-specific feedstock for recycling industry than hand sorting can do. So the SIPTex project, this is a bit of a dry slide, but the SIPTex project is a government-funded project in Sweden. It's a part of a financing scheme called Challenge-Driven Innovation. And we've reached the last stage now, which is commercial implementation, meaning that you actually realize something commercial. And in our project here, that is building and starting to run from a commercial point of view, this sorting plant. So the purpose and the goal of SIPTex, of course, is to launch the first full-scale sorting plant. There has been other smaller plants before. Wargön is a good example of a very nice pilot and demonstration plant. I should say that I don't consider us competitors. We operate at a little bit different parts of the value chain and scale. So I think it's actually great that we have both these facilities in Sweden. We complement each other very well. So with SIPTex, we are sort of blazing a trail to help make specific material-specific feedstock for recycling available and sort of increase the resource efficiency, and showing that there is actually a way to do this in a commercially viable way. So the key actors of the project is Vinnova, that's the Swedish Innovation Agency who is funding the project. The management, also starting the project and realizing the need for it and collecting all the important actors was us at IVL. I'm the manager of the project since a few months. And SYSAB, that's the South Swedish Public Waste Handling Company. They are the owners of the plant, and they are the ones that will operate it commercially. So this is another way of showing what we're doing. The smaller circle here, the reuse circle, is fairly well established, but the fiber to fiber or the high value recycling is a very immature industry, to say the least, and that's where plants like SIPTex or the Wargön fiber sort plant comes in to make reasonably priced material-specific feedstock for recycling industry available. This is the actors that are in the project. We have a very wide variety of partners. There is innovation partners like us at IVL and some others. We have public authorities, Swedish and international. We have as you can see, a few very large global actors, and we have some smaller actors, and we have NGOs and charities as well. So we think this is a very strong and powerful partnership, and we also have recyclers in here. I will get straight to the point. The plant is large scale and commercial. That means that the main differences with the Wargön plant is size and speed. We are much larger and faster. On the other hand, we are lacking some flexibility that you have at Wargön. We can only sort out for 3 material types at a time. Of course, this is something called positive sorting. So we choose which 3 fractions or blends to take out in one run. Anything that is not taken out can, of course, be run again. And we have the same capacity of recognizing materials as in Wargön, but we can only sort for 3 fractions at a time. But as you can see, the speed and capacity is very big. Another difference is that we don't sort for reuse. So anything we put on this line will have been, anything for reuse will have to be taken out before, and we are only sorting very fast and very cheap for high value recycling. The technology is similar to the Wargön technology. It's an NIR-VIS spectroscopy. This is the same technology that is widely used in plastics waste sorting. So the NIR decides which material or material blend we have, and the VIS determines the color if that's important. So we're taking different types of waste in, pre-consumer industry waste, that's a smaller part, pre-sorted textile, so textile from charities or sorters that aren't resold, and also sorting residues from collectors and sorting. So we're focusing and trying to get the inbound volumes of post-consumer material up. The plant was started to be operated at commercial speed just a few months ago, so we're still getting up to volume. And one of the key issues there is to get access to the right inbound material. We're not really there yet, but the capacity is huge. And outgoing products will be, like I said, material-specific fractions of textile for different types of recycling, chemical or mechanical, and both natural materials, natural fibers, or synthetic fibers. Pure materials or blends are available, and also color-specific sorting can be done. I don't have the time or the, I didn't dare actually even to show the film, but we have a clip up on YouTube. So if you go to YouTube and search for SIPTex, you will find a few clips, but if you go for the one called SIPTex at Sysav, automated textile sorting in industrial scale, you will see a film of the plant. You will also see some of the products that we're sorting out, and you will get a feeling for how big and fast this machine actually is. There is an option for English subtitles. It's not in the film when you get there, so you have to find the right button and click on it, but there is English subtitles there on the page. And that's all I wanted to show, and then another picture of this fascinating machine. So that's all from me for now. Thank you.
Erik, thank you so much. Fascinating and interesting to compare and contrast with the Wargön project. The critical thing is we are looking for Nordic leadership in this area. Clearly, it's throwing up so many issues, but we're on that journey. So thank you, and we wish you well with that project. And I'm sure people can contact you directly if they want to
absolutely.
Come further, or put a pair of earmuffs on and come and see the production line or the processing line in action. So
yes, if you have huge volumes of waste or you want to buy recycling products, please give us a call.
Yes, look in your children's cupboards. Okay, that's great. Eric, thank you so much.
Thank you.
Indeed, that's really exciting. Some of the work going on there. Talking of exciting, circularity, part of the key is if we actually designed the textiles, the things we wear in a thoughtful way, and if we were to dare to use new feedstock to make them, we might be on a very different trajectory to the one that we're currently on. And I'm delighted to welcome to join us this morning someone who's working on a very interesting area, fungal textiles. Akram Zamani, Associate Professor in the Department of Resource Recovery and Building Technology at University of Borås in Sweden, doing some really interesting work. I think, dare I ask, using bread waste for production of a new generation of sustainable textiles. I've been looking forward to this presentation all morning. Akram, great to have you with us, and really interesting to hear some of the research and development work that is taking place that feels as though it hits the circularity bullseye. So over to you.
Thank you so much. Thank you for the opportunity. I will start by sharing my screen. So, as you mentioned, my name is Akram Zamani. I'm coming from the University of Borås, and today I would like to have a presentation about our ongoing project, which is about production of new textile materials using the food waste. Today we heard about different problems and issues regarding the synthetic type of the textile. And at the same time, we shouldn't forget the other issue that we have in the society, which is huge volume of the food waste that is generated in the different part of the food supply chain. And our goal in this research project is to combine the two problems and try to bring in a new type of sustainable textiles that hopefully can replace some part of the existing textile materials. And this combination is done through using a microorganism, which are called filamentous fungi. And by using these filamentous fungi, we are using the food waste to grow the microorganisms and producing biopolymers that can be used for production of textile materials. Thinking about the fungi, they are eukaryotic cells. They can grow as yeast or as filaments. The type that we are interested into it is the filamentous fungi. And in the cell wall of these microorganisms, we have some very interesting fibrous polymers that can be used actually for textile production. And these biopolymers are chitin, chitosan, and also glucans. Thinking about the chemical structure of these materials, so here on the top, I have the cellulose, and then chitin is similar in the structure to cellulose and has an N-acetyl group, if you think about the chemistry. So this material is the main component of the exoskeleton of the shellfish animal. And chitosan is another biopolymer that can be produced by a chemical reaction which can happen on chitin. But the interesting thing is that if you think about the fungi is able to synthesize both chitin and chitosan using the enzymes. And both of them are available to be used for instance, textile production. But what would be the benefit of using fungi? Why are we interested to the fungi? My background is chemical engineering, and my specialty is in biotechnology. So it's the use of microorganisms to solve different problems. And thinking about the filamentous fungi, we can say that they are fast-growing microorganisms. They can grow on different type of substrate. You only need very low quality substrate so they can grow happily. And at the same time, nowadays in the industry, we have several products that are produced by these microorganisms, for instance, antibiotics, enzymes, organic acids. So it means these fungi, like the biomass of these fungi is available already as a byproduct of those industries. So if we succeed to develop the textile material, so there is a mass already available that can be used for this. And there are like several types of these fungi that are totally safe and even edible, so there is no risk for human. In our project, we have selected the bread waste because this food is unfortunately wasted a lot, specifically in the supermarkets in Sweden. So we have selected this material to grow our fungi. If you think about the growth of the fungi, so first we have the fungal seeds that we call them spores, giving them the right food so they start to grow. And they develop the microfibers. So this is like a video made by the microscope, but what we see is a mass which we collect in the end, and this mass contains those microfibers that we are trying to use them for development of the new textile and plastic materials. Here in this picture, you see different part of the cultivation process which we have here in our university. So simply we mix the bread with water, we put it in our bioreactor, and then let it grow. After a while, we separate the fungal biomass from the water, and then here we have the mass which contains our microfibers. So what we have been doing in this project is that we have tried to separate the cell wall of this microorganism or the exoskeleton of this microorganism from the other part of the fungal cells, for instance, proteins and lipids and things like that. And then we have tried to do a spinning process from this fungal cell wall to create so-called monofilament yarns. More specifically, what we have done is that we have separated the protein fraction from the biomass, and we have made a hydrogel consist of chitin and chitosan from the cell wall material of the fungi. And we have done a so-called wet spinning or gel spinning process to create those fibers that you can see here. At the same time, we have been thinking about can we create the textile materials without doing the spinning process and applying instead the wet-laid process, which is a common technique for making the non-woven textile materials? And the answer is yes. So we have been able to create a range of different products from more plastic-like materials to more textile-like material by changing the processing condition and like the additives we use in the process. And so this new type of textile material could be used for different applications. And since it's new, so we have to look for applications ourselves. Among the different possibilities, we have been thinking about using this type of materials for medical textile applications, and it's because the chitin and chitosan, which is available in our material, they are very good candidates for being used as medical textile. So that's why we have performed the biocompatibility test for our materials against the skin cells. And as you can see here in these two figures, when we put the skin cells in contact with our textile materials, at least we can say that there is not a negative response. So the cells behave like similar happy in the control condition and when they are in contact with our fibers. So this is the like spun fibers, and these three samples is the non-woven materials we have created. And as a negative control, we have used the hydrogen peroxide to see the reduction in the cell viability. We have been also thinking about if this material can like have any antimicrobial properties, and so far the results show that the textile materials made using the fungi have a strong inhibition against the growth of both gram-negative and gram-positive bacteria, which is a good news also, which help us to use this material as a source for medical textile application. This project is a 4 years project. We are somewhere in the middle. It's a collaboration between different universities and research institutes. And we have Vinnova, who has like supported the project financially. So that was all for today. Thank you very much for your attention.
Akram, thank you very much. Some fascinating research.
Thank you.
I can't wait till the moment that this is operationalized. But what it's partly doing is it's challenging us all to think about all aspects of circularity and thinking of new materials and also turning waste into a virtue is just the sort of innovation that I think we need to be seeing. So wish you well in your further research taking place there.
Thank you so much.
Some further research taking place is our next presentation, and this is about the conversion of non-recyclable textiles into valuable feedstocks by steam gasification. It's extraordinary the things that we put into our textiles, obviously because it provides utility and also economies. But when it comes to reprocessing, goodness me, it sets up huge challenges. So delighted to draw into our conversation this morning Isabel Cañete Vela, who's a PhD student at Chalmers University of Technology and doing a research in plastic waste recycling through to a pilot plant. So Isabel, great to have you with us. I'm very interested to hear about some of your groundbreaking research.
Thank you so much, Peter. As you can see, I'm here at Chalmers. I'm seeing behind the scenes here all the technical work behind. Thank you also to all of them. As Peter introduced, I work with steam gasification. I'm doing research in pilot plants, trying to find value and give value to all the waste that today cannot be recycled. And today I will be talking exactly about those textiles that cannot be recycled and how we can convert them into chemicals. And today we have been already talking quite a lot about we produce a lot of textiles and also a lot of waste. In 2019, we produced around 110 million tons of textiles, and from those, around 80 million tons became waste. And as has been already mentioned, only 1% was actually recycled to products of the same quality or similar quality, and only 12% to products of lower quality like stuffing and insulation. And the rest is either incinerated or disposed. Then here in our research group, we are trying to build a bridge to close the loop of textile waste and give value and convert this waste into chemicals. And then why is textile recycling not covering all the range today? principally today, we only have recycling of mono materials like 100% cotton or 100% polyester. We also have some polycotton or certain mix of textiles that we can recycle. And as we have been seeing already, we need a lot of sorting for that. But even though we are working to improve this fraction, we will still have a residue from those, from all the rest of textiles. Then at Chalmers, we believe that thermochemical recycling can be a pathway to recycle those textiles that are mixed together. It's basically polyester together with cotton and elastane or any kind of blended textile. Then there is 3 main ways you can recycle these leftover flows. One is the CO2 route via CCU, which is carbon capture and utilization, which is simply combust the textiles and convert the CO2 into chemicals, but this requires a lot of energy to have this process. And then you have the syngas route via gasification, which instead of combusting, you heat up the material at high temperature, around 100 degrees. Then you get syngas, which is CO plus hydrogen, and a bit of CO2. And this, compared to the route before, requires a bit less energy. And then we also have another way to recycle, which is via pyrolysis, which you try to recover the molecule where the textile was made of. If it's polyester, try to recover terephthalic acid and the other molecules to use them again. But in those processes, you also get syngas and CO, and it does normally require less energy because you have lower temperatures, 500 to 700 degrees. But still, for those textiles that are blended together and might have some contamination, it's normally not the way forward. Then here we are investigating mainly gasification at Chalmers. We actually started about 3 years ago with this concept. We work with gasification for many years now, but we started to think that it would be a way for textiles 3 years ago. Then we got the grant to do some small experiments in the lab. And just this year, we got a project together with Teco and the process industry, Vinnova, here in the west coast of Sweden, to do a pilot scale test of gasification. Then we're very happy to have this project together because it involves everyone in the supply chain, from the textile fashion industry to recycles, the industry recycling, as well as the chemical industry. This project is just ongoing, just started in January, but so far we managed to do some sorting thanks to Wargön Innovation, where they provide us with all those textiles that are mixed together, all those blends. It's mainly textiles containing mainly polyester, acrylic and polyamide. But it's all of those that are blended together with something else, either some other synthetic materials or cotton, viscose, or other natural materials. Then these textiles were sent to Umeå, SLU, to become pellets, the image you can see on the right. And just a couple of weeks ago, we tested them in our Chalmers gasifier. We tested around 1 ton at 800 degrees, and it's, the capacity of this pilot scale is 100, 200 kilos per hour. And today I will only show some small preliminary results, since we didn't manage to analyze all the data yet, since it just happened. And here in this image you can see mainly, right now you can only see the results from the lab. As you can see, the main products is CO2. 40 to 60% of the products at 750 and 850 in the lab was CO2. And the syngas was from 20 to 30% of the product. And this small white box that you can see on the bottom is other chemicals that we also obtain. It's mainly what is called high valuable chemicals in the refinery, which is benzene, toluene, and ethylene, propylene, chemicals that are very useful to produce new materials and new products. And when it comes to the pilot plant, the results were similar. I must say that, as you can see, the variation in the lab is higher, since I try more like 100% cotton, 100% polyester, and some mix in between, while in the gasification plant, it was already a mix of everything together. But we can see that at 100 degrees, we get around 50% CO2. The syngas was much lower in this case, around 15%, while the valuable chemicals, we got around 20-25% of the input. And this is because the real waste compared to the lab has way more things that are not stated in the label of the textiles. Yeah, but a quick summary, I would say, is the research is still ongoing, but I think steam gasification has a great potential to recycle those textiles that today no one found a way to recycle. Basically, once you sort the textiles, you can get all the leftover. We can gasify them and get some chemicals. And a thing I forgot to mention is the contamination. Since we have quite high temperature, any medical waste, textile waste that you have, it will be no problem because all the microbes will be killed. And also, if you have, for example, working clothes where you have paints or you have chemicals on it, it will be fine for this process. But as I mentioned, it requires maybe more energy than the other process where you recycle only cotton or only polyester. But as Maria said, we need to start somewhere, and I think it's a good start to, now we got those numbers of a real scale facility, then we can optimize the process as well as compare to others in order to see which is the pathway for those residues from the textile sorting. And while Akram was talking, I also thought if we have in the future of fungi textiles, those could be recycled this way, since it's just carbon and hydrogen. Yeah. Then that's all for me. I guess we leave the question for the discussion at the end.
Isabel, thank you so much. A fascinating presentation and really important work that you're doing there. Once again, it shows that if we design complexity in to our textiles at the start, we're going to have to have even more complexity to try and reprocess. And that's one of the great challenges we face, but very interesting research work taking place there. And I'm sure people will connect with you beyond this session if they want to know more about the work that you're involved in. So, Isabel, thank you so much indeed. Our final presentation comes from Karin Lindqvist, who's a project manager, research engineer at RISE, which is the Sweden Research Institute and Innovation Partner. And it's building on the theme a little bit from Isabel, and looking very much at closed loop recycling through depolymerization of PET and polyester waste. I won't do any further introduction for fear of getting into deep technical water, which Karin, you are swimming in very successfully. So very interested to hear about the research and application work that you're involved in that field. Over to you, Karin.
Thank you very much. So I will share my screen. Okay. So, do you see it? Can anyone just confirm you see my screen?
Yep. Yeah, it's
Okay.
fine. If you go on to full presentation rather
Yes.
than, yep.
Yes. So we have studied chemically recycled PET and polyester as raw material for additive and new polymer. And in this case, the chemically recycling concerns depolymerization, as also the previous speaker mentioned. Yeah, so the background information might be known to all of you, but PET, polyethylene terephthalate, is the number 4 of plastics produced worldwide. And while it goes to bottles and packages, it's also used for polyester yarn, which comes in application in many textile applications. So this is the question we have asked ourselves, if it's possible to close the loop for PET and polyester. Now, when we have the fossil-based raw material that is used for monomers, it will be polymerized and turned into a product. And when we reach the end-of-life product, in that case, it's a bottle. It's possible to mechanically recycle the bottle. And many times, the PET bottle then is turned into polyester fibers. But we will have a lower quality in the sense that the polymer chains will be shorter and degraded a bit for every time that it's thermally processed. So when the polyester fibers finally reach the end of product life, it's often sent to incineration. And this, of course, means the end of life for the material. But if we instead chemically recycle by depolymerization, we will break down the polymer into monomers again. So these monomers then can be used to produce a new polymer that has the potential to have a quality equal to virgin material. But the question is, does it work on real waste? So we have in our project, we have depolymerized and recycled all of the materials you see here. It's worn out straps, it's production waste from rainwear, it's production waste from thermally formed panels, and also these PET trays with the films and labels that adheres to the tray. And we have turned this into a monomer by depolymerization through glycolysis. And this monomer can be used to synthesize, for example, plasticizer for flooring. And it can also be used to repolymerize new PET. And we have used that to melt spin these polyester filaments that were woven into this fabric. So we have proved that we can recycle the real waste, as I mentioned, the PET packages with all that comes with it, labels, adhesive, coloring and covering film, and also these worn out products and industrial waste. And we have demonstrated the weaving of textile based on waste to 50%, because the recycled polyester filament was used in the weft of this textile. There are some issues concerning removing contaminations, and dye stuff is one of the more challenging one. And we have therefore worked with extraction, active carbon treatment, and filtration. And as you can see here, those small white pieces in the middle are a decolorized fabric of the rainwear waste. Yes, so we have shown that the materials resources can be utilized circularly, and the global warming potential can be decreased from 1.8 to 0.5 kilos of carbon dioxide equivalents per kilogram of monomer, according to this LCA estimation that we have performed in the project. So we conclude that real waste can be used as a raw material in the experiments, and the solvent we have also proved that it can be purified and reused, which of course is necessary to get an environmentally acceptable process. So we would like to take this into pilot scale, and we conclude that we can end incineration and instead materials recycle PET and polyester. So yes, we want to prepare a new application, demonstrate how the PET and polyester can be prepared and used as raw material for monomer production. So in this case, map and investigate waste stream and pre-treatments necessary for monomer production in Sweden, and how the monomer can be a commercial raw material for synthesis of plasticizers, synthetic lubricants, and also for use in coatings and repolymerize PET. But I would also like to mention some studies at work, because there are, of course, still remaining challenges. The decolorization of polyester textile is one of the challenges we are working on right now. What you see here is results from laboratory, where like the upper image, we have managed to decolorize these different samples of polyester, but this technique definitely has to be developed in order to make it feasible for large scale. And also when it comes to packages, we clearly see that a better sorting will be necessary, and also of course washing, because it's only a real pure monomer that will have a high value. Yes, and by this I want to thank you very much. And here are some of the project partners we are working with in this research. Yes.
Karin,
so thank you.
Karin, thank you very much. More really detailed and interesting research taking place with significant potential for the future. So there you have it. We've had 6 fascinating projects, activities taking place. Thank you all very much indeed for your presentations. I just want to steal a few moments, if I can, at the end. And if we can all just rise up in our battery-powered helicopter, because I'm just interested to take a little bit of an overview of where we're at and how we're moving forward within the overall transition to circular economy related to the clothes we wear, the textiles that we use. And I'd really like to bring in whoever would like to offer a comment. First of all, I'm just interested from the point of view of transition. Clearly, we need research and innovation, brilliant minds, chemists working out new ways of design, new ways of reprocessing, new business models, etc. Just interested whether anyone wants to just offer a comment on whether there's a sense that we really powerfully are on a trajectory towards true circularity within the textile world, or whether the more we get into this, the more we realize just what a huge challenge we face, and that we're maybe not going to be fit to meet the challenge within the time scale that things like the climate emergency require of us. So I'm just interested from those of you most involved in the kind of research and innovation side of things, what's your take on where we're at in 2021 and whether we have a half chance of delivering the circularity that we need if we're going to survive comfortably as a species on this planet? Who would like to go first? Just wave a hand in the air and then unmute. Erik.
Yes, I can go quickly. I think we had a great overview now of everything that's going on, and all the pieces to this puzzle will be needed. We are going towards circularity, and we're going towards smarter business models, as Gustav showed. But we can't forget the obscene overconsumption in the industry. That has to be reduced as well. We can come with solutions to help increase the circularity, but if we're just multiplying the consumption as projected by Maria, that won't do the work really. That's my opinion to it.
Interesting. I think Maria, you wanted to come in as well.
Yeah, I can also short comment and fully agree with Erik. I had similar things in mind, and also I want to stress to push on the consumer power we have here also. It's fascinating to hear Houdini speaking of all these different kind of new business models, but it comes down to that you and I start consuming clothing in another way, to rent, to buy secondhand, to repair, and so forth. So we can absolutely make a change. I do believe that, but we also need to take the consumer perspective and see how to work with the consumers so that they are stopping this buy and throw away habit.
Yeah, interesting. Maybe I bring Gustav in because in a sense you've got a wonderful niche set of people who maybe are sort of quite environmentally aware and love the fact that Houdini have got the soul and the spirit of this, but we're producing 100 million tons of textiles a year and we're only recycling 1%. I wonder whether there are messages for the broader world from your particular experience.
No, but I would say like the whole kind of reason why we can have circular business model is our basic foundations of not producing for short-term trends and designing for longevity, so that we can slow down the circle and then try to do it a circle kind of, because with the speed of resource outtake and the consumption of today, it's hard for especially you. Other speakers are doing a great job on kind of in the end or in the beginning, but the phase of the consumption is just it's crazy, and I would say it's a lot mostly driven by us companies who have been having an extremely profitable business model of taking resources and then selling them somewhat cheap. So I would say start from the beginning and do it right, and then try to close the loop.
That's interesting, and I'm going to bring Isabel in a moment. But interesting with the whole coronavirus and lockdown in many countries. Suddenly we've seen the obscenity of our large wardrobes being largely unused. It will be perhaps interesting as to whether this is a moment of reflection on our personal consumption patterns. But Isabel, could I could I bring you in? Do you have a perspective on the bigger picture and whether we're in the right trajectory?
I think there is many partners trying to go towards the right way, but I think Maria mentioned that I think collaboration within all the supply chain is really important to be able to achieve 100% circularity. From starting from using things more to designing them in a way that you can recycle easier, and also, yeah, at the end of the chain, which I saw all of those that are already produced and you will throw away, then find a way to recycle and use waste as a resource. Not take more new cotton, not take more oil, but use the waste that you already have, either food waste, as Akram was talking about, or any source of carbon that is not used. We could also make polyester from air if we want. Can capture the CO2 and make textile from it. And I think there is, we should look at all the supply chain together and try to find the proper way for everyone in the world being not polluted in one place and consuming in another as well. Yeah.
Okay, interesting. I just want to take it a little bit step further. You may not be aware, but the world is looking at the Nordic countries, particularly around, because you have a reputation around the whole area of fashion, textiles, etc. So we're kind of looking for you as the standard bearers of transition. I'm just interested are you doing enough this is a circular materials conference. I'm just interested, are we doing really enough to try and work through these issues, do the research, do the innovation, or and we just have to give it time, or are we just sort of kind of playing at the game and it's interesting research, but we're way off what really is required? It's a slightly challenging question, but I'm just trying to work out whether we are comforting ourselves with a number of pilot projects and one or two interesting companies doing interesting things, but actually we're way off what we should be doing as a Nordic bloc. Does anyone want to just either reassure me that every sinew is being stretched, or suggest what more we might be doing? Erik, I'm going to come to you.
Well, from one point of view, I would say that we're never doing enough, but we're doing very much here in the Nordics. We're demonstrating ways to actually close loops. We have some recyclers going commercial scale. We have seen the commercial scale sorting that I was talking about. We will have an EPR coming online within a few years. So feedstock will be starting to ramp up and generate. But I mean, the SIPTex plant that I talked about, running at full speed, that would cover a third of the waste generated only in Sweden. So that's it's not even a full-scale Swedish solution. We will need, I don't know, several more similar plants all over Europe, all over the world. But I mean, it's a question of time. It's a question of challenging the industry, but of course also legislators and politicians and the public needs to address this as well. I don't see that consumers and the industry will solve this all by themselves. We need policy to help as well.
Right. Does anyone else just want to offer a final comment on the Nordic standard bearers of transition and whether we're doing enough or what more we might be doing?
I could share from Houdini's perspective. Yes. Often we're like seen as doing everything really good, but we are still not happy about like how we make business. We want to improve. We want to have more circular business models. We want all the products to be 100% circular. Mm-hmm. And even though we're in the front line, we're still not there. So I think there's a lot of work to be done, and it has to be done quickly. I would say.
Right. Akram, did you want to just offer a thought into this conversation?
I can say that I would agree with everyone that it's not like a matter of one piece. All of the people involved in the whole chain has to work with it and try to fix the issue together. So the research is good and it has to be more and more, but on the other hand, other pieces has to work until we can come from an innovation to a solution to the society.
Yeah, so not only today have we seen pieces of the jigsaw, but all of us together are a piece of jigsaw in something larger. Maria, maybe I'll leave the last word to you.
A very short one, but I would like to emphasize the need for also reuse sorting to be digitalized and automized in a way. We all know that it's very tricky to assess a garment without touching it manually, but I'm convinced that there are ways to use digitalization to be more right when you set prices and qualities and so forth, and that will also help us to sustain garments longer in use.
Right, Maria, thank you for that. We've heard so much in this session that gives pause for thought, but also optimism of possible solutions for the future. Thank you to all of you for your presentations. Thank you also for all your work. It's not easy being at the frontier of change with the many challenges we face, but we pay tribute to you for the work that you are doing and wish you well into the future. And for all of those who've participated online, obviously through the various portals, you can connect, I'm sure, with the speakers if you want to take up particular ideas or thoughts coming from their presentations. But for now, the message is a stark one. 100 million tons of textiles are being produced every year. That is really set to rise. 1% is being recycled. We have got a huge gap in an area that is driven by consumption at the moment. Transformation is going to have to be hearts and minds, and definitely research, innovation and technology. So here's to the Nordics taking a lead on that journey forward. Thank you all for your presentations. Thank you everyone else for joining us. And I'm sure you'll join the main conference back after a break. Thank you all very much.
Thank you. Bye-bye.
Thanks.
Okay, I'm hoping that is a wrap and that